And with that, tonight, these are our hosts of the tables. This is the content we have in this fair and in this stream. Modern C++ for absolute beginners, Conan by JFrog, Undo, and the open source tools from KDAB. Because now we're actually gonna go and get started with the demos, which is the actual content for tonight, right? And here we go with demo from Undo. I think they're demoing the live recorder. And let me bring on Greg. Hello, Greg from Undo.
Hello. Hey, yeah, it's going all right. Going all right. Hello, everyone.
And let me bring online your, so here's your screen, and we're all waiting for your demo.
Thank you very much. All right, I just want to do like a couple of slides before we get into the demo, just to kind of set the context, if that's okay. So I think a lot of people know this quote from Conan: debugging is twice as hard as writing the code in the first place. So if you write it cleverly as possible, you are, by definition, not smart enough to debug it. Well, let's look at how we, well, kind of why that is, and think about how do we debug. And actually, I think as developers, we spend actually most of our time debugging, right? I mean, including the inner loop debugging. Think about how many lines of code do you think you can write and have it work first time, right? Maybe you're a better programmer than I am, but for me, it's like 20, probably not even 10, maybe. How many lines of code can I change and have it work first time? I think that number averages to less than 1, right? We spend all our time debugging, and sometimes we use like dynamic checkers, like Valgrind or sanitizers. Maybe we have them as part of our CI. Maybe we pull them out like, well, I don't know, maybe like this is the sort of thing you maybe do a lot of times. I think for a lot of people, a few times a year. Maybe use a debugger. Maybe you know, again, a few times a year, a few times a month, maybe. Some sort of fancy dynamic logging. Yeah, a lot of people don't have that. Or we just printf, and that's what we do most of the time, every time. And I think there are a couple of reasons for this. One is, I think, I'm going to be a bit controversial, but just laziness. So we all know this XKCD cartoon. Why is it compiling? It's compiling because I added the printf, right? So I can feel like I'm working, but not work. But the other reason is that it's actually better than most debuggers at telling me what happened, right? I'm trying to think when I'm debugging, how did that happen? I don't mean like, how did that happen? Or how did that happen? I mean, I had expectations of what my code was going to do, and reality diverged from those expectations. And when I'm debugging, I'm trying to think backwards to like figure out where did reality diverge from expectations. Of course, usually it does something a little bit more like that. So this is where time travel comes in. So, and this is where Undo Live Recorder comes in. So we want, if we can make the debugger just allow us to see exactly what happened, rather than what most debuggers do, which is let you see what is happening, much more powerful. So let me show you what that looks like. I've actually got loaded up here. This is our internal GitHub inside Undo, and this is a pull request that I made that's failing some tests, right? So made the pull request, kicked off some Jenkins tests, all very kind of normal. Here's Jenkins. Okay, some of the tests have failed. If I go into here, I can just like take a look at one of these at random. I've got some log information and, okay, some kind of abort. Oh, yeah, okay, look at assertion failure here, right? It's kind of normal experience, right? We look through the logs, and if we're lucky, sometimes in the logs, we have enough information to root cause the issue, and you just like, oh, yeah, I know what it is. Let me fix that and go again. But often, probably most times, we don't have enough information in the logs. We're like, that assertion failed, like it should never fail, right? That's why it's an assert. What's going on? So what would I do normally? I'd maybe add some more logging, run it again, maybe see if I can reproduce it locally. I don't need to do any of that because I've got this link to something we call the observatory. If I open this up, this is a whole bunch of recordings that got taken of my test as it ran. This test actually ran, I think, yesterday, but these are recordings of the program's execution. Various processes and things ran, but I'm going to just pick this one. It makes for the best demo. So what this is going to do now, I just clicked on that play button. This is going to provision a Docker image. It's going to check out the source code from the right version, and it's going to load up. Here we go, and it's going to load up a view through VS Code here onto my application kind of at the point that it crashed, which is going to be like a little bit like looking through a core file, but this is a recording and I get full history, every line of code that executed, and also full data. So I can actually go back to any line of code that executed and I can see all of the data. So let's just let this all get provisioned. So it's checking out the right version from Git. It's setting everything up. It gives me some tips because I'm kind of a bit lazy. It's just, usually it's a little bit quicker than this, but here we go. All right. So I've got a few things that are a bit different here. I've got this timeline. This is all inside the browser, right? So this is the test that I was just looking at. Remember, we were looking at it in Jenkins, in the Jenkins log, and we saw this assertion had failed. And I can sort of hover here and I can see this assertion fails because square root cache is 0 and it should have been 15. I can kind of hover around elsewhere and I can see that, okay, well, that's so passing in a number to cache calculate, number is 255, and what it gets back is 0. And what it should have got back was the square root, right? 0 is not the square root of 255. So kind of, okay, so if I was looking at a core file, I could get this information. It's a bit more convenient because I've got the right code out of Jenkins and stuff, but it doesn't give me enough information to root cause this, right? I need to know, why did cache calculate return what it did? Well, let's have a look out on the left here. I'm just going to move these windows around a little bit. So I've got a bunch of threads and they've each got a call stack. Actually, this is like, if I look in here, I can click this show more stack frames. This is inside libc, right? So actually, I'm not here at this assertion. I'm inside libc from where the assert failed. So what I'm going to do is I'm going to hit this, this button here, reverse step out, and that's going to pop up one stack frame, and again, and again, and once more. And so here we are inside our code. Now, again, I could have done this with a core file, but now this is where life starts to get really interesting, okay? I'm going to just wind the clock back and see what the program did and why, and see why did cache calculate return that bogus number. So go back one line. Okay, that's pretty funky. Now I'm going to step into cache calculate. So I want to know why it returned what it did. Okay, cache calculate's returning, like it's got a cache hit here. It's returning 0. Okay, we knew that. Okay, there's some threading stuff going on. I'm in thread 11 here. Maybe it's a race condition. And I've got some locking happenings. Maybe I can go back before this lock was released and let's see if everything looks sane here. So just go back a few lines. Okay, still in thread 11. It will stay inside the threads. This is before the thread was released. Now let's have a look here. So it's returning from the cache. It's returning the ith entry in the cache. I is 90. And go over here in my watches and like look at G cache 90. And if I open that up, yeah, okay, sure enough, the cache contains bad data, right? So this is like bad day at the office, right? I've got my cache contains bad data. I don't know. I need to know how that came to be. How did that happen? I don't know whether that was another thread. Is it a pointer error? Is it a logic error? All I know is something like stomped on my data structure and gave me bad data. So what I'm going to do here, this is a super cool feature. This is really kind of one of the killer features. I'm going to click this, let me just hover that so you can see it. Click this last changed button. And it's going to give me an expression. So I want to know, when did gcache 90 last change? So I hit enter. And what this has done now is wound me back in time to the most recent time that element of the cache got updated. So I'm midway through the update, actually. It's executed the first line here and not the second, so it's midway through the update. So if I go back one line now, okay, so now the data structure contains good data. The square root of 40 really is 6, like with integers. Watch the data as I step forwards. Now it's like live action replay of the corruption happening, right? Step. So that's it. That's 255 and 0 being written in there. Let's see like what's going on. Well, we're writing number adjacent and its square root. Number adjacent is -1, so the square root is garbage. Why am I trying to take the square root of -1? Well, I could, I'm getting pretty close now. I could do this by code inspection, but as this is a demo, let's do it just a slightly different way. I'm going to use the last command. I've got the command line here. So why is number adjacent? -1. Okay, it's being set here, number adjacent. Well, it hasn't been initialized yet. It's being initialized to number, which is 0 -1. So here's the bug. called the function with a number of 0. It returned the right thing. It returned 0. But as a side effect, it left one entry in the cache in a bad state, right? Because it was calculating square roots either side on the basis of some kind of locality of reference. And I didn't notice until sometime later in the execution, different thread came along. Actually, in this case, it looks like it was the same thread. Usually it's a different one. Anyway, a thread, and let's, the same or different thread came along and tripped over that bad data, and then the program assert failed. Now, this is a trivial program, right? It's like less than 100 lines of code. It's just to show a demo. We want to show a very quick demo in like 10 minutes. But suffice just to want to say that this scales, right? So our customers are people writing really, code at scale, millions and millions of lines of highly optimized C++, and they use this, all the time, every day, even in those environments. So that's it. That's the quick demo. I will be hanging around in the lounge afterwards to take any questions. Thank you very much.
Thank you. That was an awesome demo of the live recorder from Undo. And yeah, Greg is an expert in many things. So we will be having a table for Undo in the launch later. But now let's continue with thanks, Undo. This is our next guest and our next topic now. There's a new book, actually a new version of this book. The Modern C++ for Absolute Beginners book has a new version, second edition. And we are going to talk with the author now about this. Let me bring on Slobodan. Hello, Slobodan.
Hello, Jens.
See, also you're sharing your book, so I can share that. So tell us about the new version.
Yeah, sure. So this is the second version of my first book, which is a Modern C++ for Absolute Beginners. But I like to refer to my book by its second title, which is a friendly introduction to C++. The book introduces the language itself, the standard library, and modern C++ standards. In the second edition, I've covered some of the features in C++ 23. Also, the second edition features more diagrams. And one of the feedbacks I often received is that people would like to see full source code projects. So I've included 6 new full source code projects in addition to the exercises. So I'm very much looking forward to having a discussion with people on Hubilo platform. And yeah, thanks for having me, and looking forward to presenting about my book.
Okay, what can you show us about you? You have the book here. Can you show us a chapter, an example?
Sure. Basically, the book is divided into, let's look at the table of contents. The book is divided into basically 3 parts. The first part deals with the language itself, the basic facilities in the language, followed by the abstraction mechanisms such as classes and templates. Then we move on to the standard library, where we cover some of the most used algorithms and containers, etc. Also, finally, we are addressing the notable features introduced in C++ 11, 14, 17, and 23. And finally, at the end of this book, there are basically 6 source code projects fully written out with the basic commentary, etc., etc. So after each of these theoretical introduction, there is an exercises part with solved source code exercises, which I've also included after every chapter. So I'm very much looking forward to any questions you might have about this book, and looking forward to it once again. Okay, thank you.
You're welcome. So if you're curious about his book, he'll be later in the launch. And yeah, I've heard very good things about your first version, and it's very popular. I can kind of see at which books people look, and your first version has been in the top 5 there at Meeting C++. So definitely there has been some interest in that book. And now we have a version which also covers the newer standards. Maybe we should talk about that a little bit. What's like your insight with C++ 20 and 23?
Well, basically, in the second edition, I wanted to focus more on. I've revisited some of the chapters. I didn't, as you said earlier, there isn't so much material in C++ 23 to be addressed. But basically, what I put my focus on were addressing and readdressing a couple of topics which were introduced in the first edition. And I also introduced many more diagrams. People wanted to see more diagrams, visual representations of certain concepts, so I did that. I've also updated a couple of exercises, and mainly what people wanted to see were fully written out source code projects written from zero, and then we build in complexity, and the commentary is also there, etc., etc. So we build in complexity step by step. We start by zero, and then we are expanding. So I'm very much looking forward to any questions in the QBuild platform after this presentation.
Okay, so if that's everything you have to say about your book, then we'll look forward to coming to your table and meet the author and the book. So let's see who is next. Thanks, Slobodan. We have Conan as our guest now, but I need to find my window again. Here we are. So here's Chris from Conan, and Chris, I think you have a demo about Conan.
Yes, I do. I have a few slides and a quick demo, so I'm going to share my screen for everybody.
That's what I'm after. Yeah, so Conan 2.0 has been released in February, I think, and it's been long awaited, and it's great to have it. So let's see what Chris has to say about Conan 2.0 and Conan in general. Let's go.
So just a quick introduction to Conan 2.0 for the tool fair here today. My name is Christopher MacArthur. I'm the Conan developer advocate. If you're on any of our social medias, you'll definitely find me. We're in a bunch of different places like the CPP Alliance Slang, the hashtag include Discord. You can follow us and keep up to date with all the different releases that are going on. So one of the first questions I always get is, what is Conan? So it's a C and C++ package manager. And the role of this is really easy. It's just to simply install dependencies. We've all had that frustration of, I'd like to try out a new project, but the building 3 or 4 different projects, putting and installing them all in the right place, configuring the system, it's quite a hassle at times. And being able to just quickly develop and prototype things is one of the most convenient features of a package manager. So the distinction between Conan and a lot of the other package managers is it focuses on building and distributing the binaries. So when you're talking about things like ABI compatibility, binary compatibility between different versions, being able to model that, track that, and make decisions around it is where Conan's strengths really lie. So we have JFrog's Conan Center. I've been contributing to that for several years now. There's over 1,500 open source projects, and it's built in over 100 configurations. So you can see this in the demo very soon, but I'll show you that you can quickly just install the dependencies needed. So Conan is open source, it's MIT licensed. It's a distributed model, so there's one client to many servers. It's scalable and flexible, so you can have different combinations of remotes and servers working combination. It supports all the major build systems, so CMake, Meson, AutoTools, any platform, Windows, Linux, iOS, Android, your heart's content, embedded devices as well. And it's more than just CMake list.txt. So being a Python package manager really gives you some flexibility so you can do more things and more completely. So let's say we just have a simple consumer example, right? So I want to make an app and it's going to be version 1.0 because I'm real fancy. You can just make a Conan file.txt. You don't really need to get into the Python, and it's a very easy syntax. Requires speedlog 1.11.0. We're going to be using some generators. This is Conan's language for the integrations for build systems. So you can see here we're going to use CMake toolchain and CMake deps, and our layout for this project is going to be CMake because it's a CMake project. So we can just git clone our app. We could cd into the repository and do a Conan install. And that's like the easiest way to get going. But the secret here is the dependency graph. So what you didn't see in the previous slide was this dependency on FMT, so the format library. So my app is going to have a direct requirement to speed log, but that speed log is going to have a recipe and it's going to have a requirement to FMT. And that transitive dependency is carried through the Conan model graph. And being able to make these distinctions and understand these things, we get to do fun things like having requirement traits. So we know whether or not the header libraries are exposed, whether you need the symbols to link against, whether it's a DLL that needs to be copied at runtime. You can make more informed decisions when you're building and deploying your app, and you can do some fun optimizations in that. So I mentioned a recipe. So our app here is going to have one. We're going to use Conan to build and distribute it because that's the next step. We figured out how to install our dependencies, but we need a recipe for how do we build and package this. So we're going to make an app and it's going to have a binary and it's going to have a Conan file. And there's going to be a source method, a build method, and a package method. And this works just the same where you clone your repository. And instead of doing Conan install, we're going to do Conan create. So fun little demo. I have here a terminal. We're already in our app directory. So if I just do ls -la, you can see minus the bad text coloring, there are a few directories going on. So we have a source folder here as well as a test package. And we can see here our confile.py. So if I cat that Conan file, you can see here we have a handful of things. I cheated and just used one of our nifty little commands in Conan. So if you do Conan new, you can actually just generate yourself an example recipe, which is what I did right here. And you can see here we have our layout, which should match what you saw previously in the Conan file.txt. Most of these things translate over. We have our requirements, generate, build, and package. So these are the different methods that Conan can invoke, and this is how you teach it to build and package your software. You can see here for our binary configuration, our settings are operating system, compiler, and build type, architecture. And this is just how you describe things. There's some fun fill-ins so you can do your metadata. And here we're going to be making an application. So easily laid out. So if I go back to my cheat sheet and I steal my command, I can run this here. So I'm going to compile this with C++14. And you can see Conan will go through and work, and it'll build our app. So our graph here, you'll notice it's going with our app, and it was exported, so it was in our cache. And you can see our dependencies here. We have speedlog and FMT. So our version range here. So I need version of speedlog, anything greater than 1.10, and it resolved that and it found the latest, and it turns out it was a 1.11. Compatibility. So depending on your C++ standard, you can get different binaries. The default compatibility in Conan 2.0 is very easy. It accepts any CPP STD, which is generally what you would expect most of the time, that most of them should be compatible. It is a plugin, so you can change and customize it however you like. Here you can see our requirements. These are the different binary packages that it resolved to and found. And it generated our files for us. And this created our package. So the introduction section to the new Conan 2.0 docs is going to be your best friend. It's a narrative story. So similar to how we saw from Sloban for his book, where there's like real code examples, all of that is here present with Conan as well. It makes it very easy to get hands-on and try it. So why would you pick Conan over the other ones? And I touched about this a little bit earlier, but its focus on being able to package and distribute software is one of the key aspects of it. And it also gives you that flexibility so you can build a framework for doing DevOps. DevOps isn't really something we talk a lot about in the C++ ecosystem, but spoiler alert, you've been probably doing it this whole time with building and saving packages somewhere. Those binaries, if you build and debug and release or different compilers and platforms, you've already been doing DevOps. So Conan just gives you more tools to manage that and do it better. And you can do things like modeling the platform configurations and linkage between libraries, which is very convenient. What's new in Conan 2.0? Quite literally everything. So there's been 5 years without a breaking change. And that commitment to stability is still true with Conan 2.0. So about 60% of the code base is new and about 20% is backports. But the example I just showed you is completely compatible with Conan 1.x as well. So you can do the latest in Conan 1.x and then plan your migration over to 2.0. And this was done intentionally, and the design was really thoughtful behind this. So this is a slide just to show all the different changes. On the left-hand side, you can see a list of different breaking changes. These are more structural changes to how the client works. And on the right-hand side, you can see a whole long list of new features. And this will give you a good overview of like what to expect. I mentioned the plugins. In Diego's CPPCon talk, he used the expression death by 1,000 bytes, and that is absolutely truth. So one of the changes in Conan 2.0 is you have the power to help yourself. There's a profile checker, command wrapper, and package signing, to name a few, and this will really make it easier for people to try things out. So new graph model, new plugins, extensions, deployers, binary compatibility, things I didn't mention, multi-revision cache. There's new package ID modes. There's lock files, got a huge revamp, which is super good. Configurations environments got an overhauled, package immutability, and so much more. There's a page on the docs, what's new, and you can learn all about it there. Some more resources if you're curious. There's an ACCU talk by Diego a year ago now. We did an introduction to 2.0 blog as well. The tutorial, which I mentioned. If you have questions, the official place to get help is the Conan issues on our GitHub repo. If you want community help, I highly recommend our CPP Alliance Slack channel. It's one of the most active in the C++ ecosystem, and it'll definitely give you a good overview, and people are definitely helpful. So, and if you want updates, Twitter. I run the Twitter. I do make typos. You can make fun of me. I appreciate it. Thank you very much. Pip install Conan. That's it. Easy peasies.
Thank you, Chris. That was a nice short demo, and more about Conan on the table. So need to go on my slides again. And thanks, Conan. And next we have KDAB presenting on their open source and Qt tools. So let's bring on Kilian, and we're ready to go.
Hi.
You need to add yours.
Yep, that looks better. So welcome everyone. I'm Milian from KDAB. We have quite a few open source tools. I'm mostly interested in two of them. HeapTrack and Hotspot is what I've been doing. Those are profilers for Linux. One, HeapTrack, is a memory profiler, so heap memory profiler. And another one is Hotspot, which is what I'm going to talk about later, is a UI for the Linux perf subsystem. And we also have tools like Clazy, which is a LLVM-based static code analyzer especially for Qt. So it helps you, for example, to port your code from Qt 5 to Qt 6 and finds little paper cuts that slow down your application and whatnot. And yet another pretty popular tool of ours that is also open source like the others is Gamma Ray, a Qt visual debugger and introspection tool. All of these tools are pretty interesting, I would say, and I could easily fill 10 minutes each, but today we'll talk just about Hotspot. And the thing here is this is mostly interesting for Linux people, but I guess or hope that there are quite a few of those in the audience. And historically, and if you look at how you do profiling on Linux, then sooner or later you will stumble over the Linux perf subsystem, so the perf record and perf report commands. And those are pretty damn hard to use on the command line. Just to give you a quick example, I hope you can roughly read what I have here. If I go to some application that I want to profile, then I used to be, I used to have to do something like perf record, and then I have to remember that I actually want to do dwarf unwinding, and then maybe I want to enable the Z standard compression, and then I want to run my application. And then it did something, and if I report it, then all I get is this fancy or not so fancy standard console UI that is, in my opinion, not good enough. So I set out a few years ago to write Hotspot, which is essentially the same thing that I just showed you on the command line using the ready-made perf tools, but in a UI package built around Qt 5 and KD frameworks. And the notable features really is that it's much, much easier to use. And it tries to give you some context-sensitive information, which is what I'm going to show you next. And a few other things that I will not show today, like actually being able to very easily access the profiling data that you recorded on an embedded target. So let's say an ARM device, Raspberry Pi, you name it. And then you copy the perf data file over to your development machine, maybe different architecture there. And then you just connect to the sysroot and the debug symbols there and analyze everything. And that just works. So let's talk about some demo time. So as I showed you before, I actually recorded some data. And instead of just saying perf report like I did before, I can just use Hotspot as a drop-in replacement for perf report. It will look for the perf.data file in the same directory, and then it will actually look at what is needed to analyze the data. And now it's done. You get a little overview page, hopefully looks like that. You might have seen the little progress bar earlier, and that actually was me downloading debug information through debug info D, which is pretty epic nowadays. And then the first thing that you really should look at is either the overview, or what I do is the flame graph. So if you haven't seen the flame graph yet, please educate yourself on this great innovation by Brandon Gregg. It is essentially a visual representation of this tabular data that you probably know from any profiling tool. And it literally just divides the full width in fractions. So if you can read a thing here in this tower city landscape, then it means it has a fractional large contribution to the overall cost. Perf is a sampling profiler, so that translates very nicely. So 66.8%, which you can see in the bottom corner, is in this draw Mandelbrot file. Pretty clear. And now I can easily say I actually want to colorize it by some demo, by the binary, or whether it's in kernel space or user space. So we can see here a few red towers that are kernel space, but the rest is all user space here. And I can see what is system and what is user space. And these are just different ways to slice and dice the data. Eventually, you will essentially go from top to bottom, look for a white thing that you have under your control. And in this case, it's this draw Mandelbrot one. And as you can see at the bottom in this timeline view, all the threads that we recorded and the CPUs. And when you hover something, you actually get to see when a sample was recorded that contained this frame on the stack as well. And okay, now let's assume I found something here, right? Draw Mandelbrot. How do I figure out where in the code that is? You can right-click, view caller callee, and then it's yet again a different way to look at the same data. And here on the right-hand side, you would have a list of all the lines of code that actually got recorded. You can sort by inclusive cycling cost, and then you would see, okay, Mandelbrot line.cpp line 40 is apparently costly. And I can double click it and open it in an editor of my choice. And I would see here is something that is apparently slow. A different way to look at the same data is if you go to right click and then disassembly. And this is essentially kind of like Godbolt, but integrated and for profiling data. So we also disassemble the data just like Godbolt does, and then try to do this, what's it called? Basic building block colorization. And then you will see the same line here that I just opened in the editor with the high inclusive cost. And I can also look in the raw disassembly code and find the equivalent costs there as needed. If you need this kind of low-level data, it's all there now, which is pretty cool. And there are some more improvements coming along in this area. So I would say for the 90% use case, this is all of what I'm doing in my daily job as a software developer when I need to do profiling of C++ code. Hotspot is trivial to work. It's super fast, and I just do this a lot. Now, one thing though that, I mean, many tools can do something like that pretty easily, right? But one thing that is pretty nice is I can also record data. So I don't even have to remember these arcane command line tools. And I can enable more advanced path features. For example, the off-CPU profiling, which is pretty nifty. So let's start recording. And I get here a example application. And now if I try to resize this window, it's really, really slow, right? And well, yeah, I deliberately wrote very slow code here. Let's close the application. And if you are interested in what command was run, you could even just copy and paste this out and put it in a shell script or whatever. There's no magic going on here, really. Now we can view the results. And again, some debug info D. That should be pretty quick because most is already cached. At least I hope so. Famous last words. Yeah, okay. So now this is done. And the summary in this case is actually pretty interesting because we see that for some reason this application starts 210 threads, which is pretty stupid on a laptop like mine, which only has 8 cores. Similarly, on average, just 0.4 cores are running, so not a lot is happening. And down here in the timeline, you can also see that really being the case, right? Let's jump over to the flame graph and make that more clear. So first of all, we have this list of CPUs, and there is stuff going on, but not a lot. And then down here, I see apparently some threads get created, and then they get killed, and then more threads are created, and then they're killed, and more and more and more, and so forth. This is very, very bad code. Similarly, let's try to figure out where the code is actually sleeping. So as I said in the summary page, it says on average, most of the threads are just sitting around idly, not doing anything. And because I did this off-CPU profiling, I can now select a different cost source for the flame graph. So by default, it shows me the on-CPU cycling cost, sampling based. But now I can switch to off-CPU tracing costs through the scheduler trace points. And then the flame graph looks totally different. And this is actually a sleep time cost now. And when you look at this, a larger screen is useful. But let's have a look at what happens when I hover the timeline. I actually see the towers at the top getting highlighted as well. And for example, here, this thread is the so-called debug thread. It's I can actually ignore that. Let's say exclude this thread. I'm not interested in that. Similar, here is a event thread, which is really just this little part of the flame graph here in the middle. So again, let's say I'm not interested in that. I'm going to exclude that thread as well. And then what else do we have? We have the main thread sometimes not doing anything because I simply didn't interact with the window that you saw. So if I zoom in here, I can also say, let's exclude this whole stack whenever this frame is encountered. And bit by bit, I can clean up my flame graph that way until I eventually find the needle in the haystack, which is in this case, this left big chunk where a function that I have under my control apparently tries to lock a mutex. And again, I can just go to view caller callee and sort by the off CPU time and find, so here again, it's on the right-hand side. And when I sort by the off CPU time, I go to Mandelbrot.cpp line 124. And indeed, I double click and I instantly see the lock that is being held here, which is obviously pretty badly placed. So let's quickly optimize this. I just reduce the size of the critical section, and then I will recompile. Give me a second, and then I'll just quickly rerun that to show you the advantage here. So I just re-record and I resize, I close, I view the results. I wait for the cache to be filled, and now things look much better than before. There's actually some threads being used in parallel. On average, not much, because I'm actually still not interacting with the main window all the time. But when something is happening, so for example, in this area here, let's filter in on that, then you can see all threads are more or less busy doing something. And the flame graph looks nice. I can again look into what is now on CPU, what is off CPU, just like before, and then further look into my application, try to come up with additional ways to speed it up. So yeah, if you have any more questions around Hotspot, HeapTrack, Gamma Ray, Clazy, any of the other tools, come by, visit us at the virtual table, and thanks for listening.
Thank you for the demo. All right. Thanks to Milian from KDAP. And this is now the end of this kickoff. Join us now in the lounge.